Good day, guys. So, this is water treatment technology where we'll be talking about water treatment and wastewater treatment solutions, as well as plant operation solutions, because basically they go hand in hand together. And also, not forgetting your piping and also your valves, which form part and parcel of the maintenance when it comes to water treatment solutions in a way, and as well as different water treatment methods that will basically be going through that goes with the processes that are involved in treating your water. All right, guys. So my name is Mr. TP Kamesi, and I'm actually a lecturer by profession in one of the colleges in South Africa in the Eastern Cape, okay, specifically in Queenstown. So when it comes to what I actually studied for, I initially did civil engineering in university, a diploma in that, and then I also did my BTech in civil engineering. Then I majored whilst I was doing my BTech in civil engineering, I majored in water treatment engineering basically, and thereafter I also did my postgrad in education, just so that I can fit in nicely into the education sector, um, coupling with my engineering qualification as well as experience. So typically this is how I normally just structure how to start up with a water introduction, okay? Water treatment introduction, basically. How do you get your water treatment plant and so forth and so forth, okay? So it firstly starts with the population, okay? People, there's normally a demand that a certain community doesn't have water supply, okay? So what do they then do? They go to the municipality, okay, in most cases, which will be our client, okay. Municipality normally is the person that will be paying for the project to go through so that people get water at the end of the day, okay. So then the client then finds a consulting engineering firm, okay, just to give them a research or report, if I can put like that, a feasibility study, that's the exact word, to say what is actually needed for such a project to go through, basically, okay. So the consulting engineer will then go to census to find the population again, how many people are actually in the community, okay. You need that in order to go to a particular source, okay. A source will also get into that, basically where you'll be getting your water from. An example will be a dam, a river, such things, okay, whereby you'll be sourcing your water from, okay. So a consulting engineer needs to do study, basically based on the source. From that, after getting that study, they then also check what type of water is there. Is it going to be possible to treat that water? Is that water going to be enough for this population? Okay, so there's normally a design period, let's say about 30-year design period or 50-year design period. Is that water going to be able to last this population up to 30 or 50 years? Okay, so that's the study the consulting engineer needs to do, and thereafter they also need to come up with maps or drawings in particular of this project that's going to be done, okay. uh, Going from the source, laying your pipe work, making the actual building of the water treatment works, and also going to your reservoirs where water will be stored, from there to the households, okay. So basically all of that work has to be done by the consulting engineer. Okay, so after that, then the consulting engineer will then hand over those drawings to the construction company that will be actually doing the physical work, like your buildings, water treatment plant, laying of pipes, installing valves, installing fittings. All of that will then boil down to the construction company that will be appointed to do the actual project. Okay, and obviously the consulting engineer has to oversee all of that work during that period of the actual project. So guys, basically these 8 steps cover your water treatment processes. That's the main or a core portion of water treatment. Okay, to know different steps of water treatment. They're not only limited to these. Okay, um, it's a matter of method. Okay, other people have different methods which are also used out there. Okay, this is the simplest that's out there that you most commonly find with each and every water treatment. Okay, so the first one being your preliminary treatment. Okay, then secondly we have got our coagulation. Thirdly there is the flocculation. Number 4 is sedimentation. Number 5 is stabilization, also known as softening. And number 6 is your filtration. And then you have your disinfection. And then lastly, when you're done with all of that, okay, where you store your water, which would be your holding tanks. Okay? So after this, then we'll then explain each of these treatment processes, what actually happens within these different processes. All right, guys. So looking at the first step or process, okay, we'll now be focusing on preliminary treatment. Okay, it is subdivided into 3. Firstly, when you get to a water treatment works, you normally see screens. Okay, screens, they just normally look like a fork. They're normally diagonally positioned. Okay, and then you would normally get your plastics, rags, and so forth being held up, okay, by those forks that you normally see, and water and other smaller particles, solids, will be able to go through. Okay, but the larger solids will then be held behind by the screens. So that's the first process that you normally go through under your preliminary treatment. Okay, and thereafter you'll also get pre-chlorination. Okay, pre-chlorination, basically you are dosing a bit of chlorine right at the beginning of your water treatment processes, just to try and avoid having algae build up during other processes during your water treatment. And then thirdly, you'll have what's called pre-sedimentation. Okay, it's also known as, you normally get grit channels. Okay, they are called grit channels. Okay, they are long, narrow channels whereby the velocity is normally quite slow of the water. The reason for that is so that any particles that were not able to be held up under your screens, okay, now get a chance to settle and be able to be removed under your grit channels, okay, also known as your pre-sedimentation. So that's it for preliminary treatment. Then now we go into coagulation. So guys, this is our next stage, which is known as coagulation. Okay, so we normally have water from our previous stage, okay, into the next stage, which is coagulation. Okay, Now it's also called influent because it's water getting in before the treatment. Okay, and when it goes out, then it will be known as effluent after the treatment. So as this influent gets into here, into this basin, it will be dosed. Okay, as it's being dosed, okay, with a coagulant. There are various coagulants. Also, there is lime, there is alum, but we'll get into that later on. So as this influent is getting into this basin, also being dosed, this velocity in this water in this basin is actually very fast. Okay, the reason for this water having a fast velocity to normally be stirred around, so that when you are dosing that coagulant, it's able to be spread all around the basin. Okay, so what's the reason for dosing this water? What's the reason for putting in that coagulant? When we get our water, it normally has a certain charge to it. Let us say it's normally positively charged, and therefore the coagulant, the actual chemical that will be dosed in there, will have a negative charge. Yeah. So what does that then do? Remember, we said that there are solid particles that were not held up in your screens. They also pass through grid channels. Now they're here. Okay, so we are trying basically to get rid of those. Okay, so by applying that coagulant, you are trying basically to give the water and the what's this thing, the solid particles that are floating on the water, you're trying to bring them together. Okay, and then when it comes to the following stage now under flocculation, we'll then discuss it further, because that's where it makes more sense why we actually need this coagulant. Our third step now is flocculation. Okay, so the velocity that we had that was moving this water at a very high speed is now being slowed down. Okay, the reason for that is so these particles that are in suspension, okay, will now try to move together because of the chemical that was dosed in there. Okay, they're now trying to move together. They're going to coagulate together, and basically they're going to form what's called floc. Okay, it's called floc. Okay, because of that chemical, they're able to adhere together, and then they form floc. By so doing, okay, immediately something gets bigger in size. It changes the density. By changing the density, basically you're changing also the mass, because your density has got a unit of kilograms per meter cubed. So you've changed the mass, you've also changed the volume of that particular solid. Okay, by so doing, we'll then see under sedimentation what advantages that does for us in terms of trying to clear out this water from solid particles that are in suspension. Because we should also remember, the more particles we have in suspension, the higher the turbidity is. Okay, turbidity basically also affects the color of water. Turbidity just is made up of suspended solids onto our body of water. So guys, our fourth step or process is also known as sedimentation. Also, again, as I said before, also known as clarification. Okay, so now our water has moved from our flocculation and coagulation into a sedimentation tank. Okay, this is a sedimentation tank. famously known as the Dortmund sedimentation tank. Okay, it's a circular tank. Okay, there are different ones. There are horizontal ones, rectangular ones, so many others, but we'll go through those in another time. So we now have those flocks that were floating. Okay, as we had said before, they are now bigger because they've clumped up together due to the chemical that was applied, and they got together, they adhered together. Therefore the density changed because they got bigger in size and also in shape. Okay, so by so doing, remember, water normally has a density of 1000 kilograms per meter cube at room temperature. By saying that, basically water changes its density based on its temperature. Okay, hence you are able to get ice floating on water because it's got a lower density, hence it is floating on water. Okay, same goes now for the flocks that are there. Before, those flocks, in fact they weren't even flocks, they were just solid particles that were in suspension. Okay, they had a lower density, hence they were floating. But as I said before, under flocculation, those flocks came together, or those solid particles came together. They were now known as flocks, and they changed the density. By changing the density, now they are heavier than the water. They've got a bigger density than the water. Therefore, what's going to happen to them? They are going to settle. Okay, they're going to settle right at the bottom of the sedimentation tank because now they've got a bigger density than the water. Okay, by so doing, by having those flocks settle right to the bottom, they are now known as your sludge. That is sludge. It's basically a whole lot of flocks that came together, and you have that muddy type of solid that's there, known as your sludge. Okay. Now this is our fifth process in our water treatment processes, known as stabilization or softening. Okay, so basically, after we had applied our coagulant under coagulation, the pH of the water would then change depending on which coagulant we were using. For instance, take lime. Lime would normally increase the pH of the water. And bearing in mind, our pH would range between 0 to 14. Okay, that's too acidic, that's too alkaline, and basically that is neutral at 7. So by applying our lime or our coagulant, okay, it would normally increase our pH to become more acidic. Okay, so you can't really drink water that's too acidic, it's too hard, and therefore what would normally happen is that we would apply what's called softening. What really happens under softening, take for instance, you take the body of water, apply carbon dioxide. Carbon dioxide would then try and soften. Basically it will try and bring down your pH to become more neutral, hence we're saying that you are softening the water. Now this is our sixth water treatment stage, okay, and it's called the filtration. So basically, if you think of it like using common sense, you're just filtering water through a certain medium. Okay, media, basically whatever you be having, could be cloth. For instance, we are using sand in our case. and this type of filtration is known as a slow sand filter. Okay, it's normally used at small plants whereby you don't get a lot of water that needs to be treated or filtered through on a daily basis. So how does it really work? We normally get our water getting into the filter bed, and there's our water. That water should at least have a depth of about 1 meter head. Okay, the reason for that is so as to have enough pressure head. You need water to be pressing against water basically, so that it goes through the pores that you get, or perforation that you get under the sand, through into your gravel, up until it gets into the perforated part and goes out over there. So what then we normally have between our sand and gravel? The sand particles are far smaller than the gravel, so obviously they would want to get into the gravel and end up clogging. So what we then do, we normally put a sheet known as bidum in between. Okay, normally put a sheet, a thin sheet known as bidum in between them, so that they don't mix together, because once they start mixing, it will end up clogging. Okay, and after you have filtered your water through this bed slow sand filter, that water should at least be anywhere between 3 and 5 NTU. Okay, NTU, that's the unit used for turbidity. Okay, try though by all means not to exceed 10 NTU. By having it between 3 and 5 NTU, that's a successful run. You can then go to the next stage. So we can basically say this is our last stage in a way, in terms of treatment, which is your disinfection. Okay, disinfection, we normally use what's called chlorine, because it is far cheaper than others. There are others that are available, polyelectrolytes and so forth and so forth, but your chlorine is far cheaper than others, and it is commonly found. So basically it's easier to use in a way. Okay, hence we end up using chlorine for your disinfection. So another way, for instance, I remember some time back there were people, even today there are still people that don't have access to clean and safe water. So there's a easier method of purifying your water at home. Okay, whereby, let's say you get a bucket of water from the river, and you have to filter that out. You can use a t-shirt or certain cotton that you can use. You pour that water through. Basically you are filtering it out. Okay, and you pour a certain dosage of jik. Why use jik? The reason for that, before you even use jik, you boil the water. Okay, and after doing so, you have to pour some jik into it. Can't really recall the amount of jik that you have to pour per 20 liter. But the reason for pouring jik is that it contains chlorine into it. So hence you use it as a disinfectant. Same goes with a swimming pool, for instance. When you want to disinfect a swimming pool, what do you use? Use HTH. Okay, HTH, what does it have? It's got chlorine in it. You normally even smell that the smell of it has got a choking effect. Okay, that's the chlorine that's normally used. And then lastly, we'll just have your holding tanks. Okay, that's on number 8. Basically, our holding tanks are just reservoirs that are at our treatment works, and they're just used to store water before the water is distributed to different communities out there that actually need the water. So from there, that water is just pumped out. So yeah, that would be your holding tanks, and that just sums it up in terms of the water treatment stages that we go through. As I said before, you are not only limited to these, but you will normally commonly find these in almost each and every water treatment works out there.